but it doesn't reflect the whole world, right? One of the other really fantastic things we can do with the handler is we can both handle our DSC engine, but any other contract that we want to simulate for as well. And there's a lot of things we want to take in mind when writing these, especially the other contracts that we interact with. What are some of the other contracts that we interact with? Well, one of them is going to be the price feed. One of them is going to be the WETH token, the wrapped Bitcoin token. So our handler should probably also show people doing random weird things with WETH and wrapped Bitcoin, right? Because people are going to do random weird things with both of these tokens, and we want to make sure our system can work with them appropriately. Now, I'm actually going to skip them for now, but I am 100% going to do one with price feeds, because price feeds are definitely a system that can change and definitely a system that greatly affects our protocol. So we're going to include price feed updates in our handler. So what we're going to do is we're going to go ahead and do import a mock v3 aggregator from //mocks/mock v3 aggregator.sol. Or where is this located? Oh, just one like this. Okay. And this mock v3 aggregator has some functions that allow us to just easily update an answer, right? Which is something that we want to do. We want our protocol to be able to easily update answers. So we'll take this mock v3 aggregator and let's at least get the WETH price from our system. So I have a view function, dsce.get collateral token price feed, and I'll pass the address WETH. Oops. And I'll say ETH, and I'll make another variable, mock v3 aggregator, public ETH USD price feed. I'll say ETH USD price feed equals this, and we just got to wrap this up as a mock v3 aggregator like this. And great, now we have an ETH USD price feed. And now we can add a new function in here. So we have mint DSC, deposit collateral, redeem collateral. We can add a new one called function update collateral price. And we'll do a uint 96 just so that the number isn't too big, new price. And then we could also randomize the collateral, but for now, we'll just have it be the ETH USD. So we need to convert a uint 96 to an int 256, new price, int equals int 256 new price, because price feeds take int 256s. Oops, sorry, this should be in. And to convert a uint 96 to an int 256, we actually have to wrap it as a uint 256 first, and then to an int 96. Dot update answer, or set price, or whatever we want to do to this new price, like this. Boom. And now, simple as that, we have an update collateral price, well, an update ETH price anyways. So now we can do three things in our system. We can update the price, redeem collateral, deposit collateral, and mint DSC. So before we actually run this, what do you think? Do you think we'll get an error? What do you think will go on? Let's run this. Whoa, it looks like it found a sequence. It found an issue. The reason, assertion violated, which means that our invariant here was broken. The WETH value plus Bitcoin value now is no longer the total supply. So let's scroll up. Let's see what the issue is here, all the way past everything. And if we read the sequence, we can figure out why this broke. We can see exactly what happened. Okay, so first it called deposit collateral. Okay, cool. So it deposited some collateral. And then we minted some DSC. Okay, cool. We minted some DSC with some stuff here. And then we updated the collateral price to 471. So as we know, our handler update collateral price, if we scroll all the way to the bottom, update collateral price 471 updates the ETH collateral from $2,000, which is 2000 E8, to 471. So this, remember, is 2000, 1, 2, 3, 4, 5, 6, 7, 8. It went from this to 471. So of course it reverted, right? Because people minted a ton of collateral. They deposited collateral. They minted a ton of DSC, right? Look at this input. It's massive. And the system broke. And if we run this again with fewer Vs, right, VV, we'll be able to see that total supply. If we scroll up, we'll be able to see the WETH value, wrap Bitcoin value, and the total supply here. So actually, it looks like in this one, it's set the new price to 3. So obviously, the WETH value is probably 0 or just about 0. It let them mint DSC because originally the collateral was worth something, and now it's worth almost nothing, right? So this is an important thing for us to take in mind in our system. Hey, if the price drops or spikes quickly, our system is screwed. Our system is busted. And this is something we would want to know about and potentially go back in our code and fix. Hey, what do we do when the price plummets in a single block? Right now, we have kind of this assumption in here where we have this liquidation 10% bonus, and the collateral always needs to be 200% over collateralized. With this, we're saying, okay, between 200% over collateralization and 110% over collateralization, as long as our system is within this, it's still safe. I mean, obviously it's better if it's above this, but as long as our system is within this, it's still safe. But if the price plummets of some collateral, and let's say that's the only collateral, maybe we get to 50% collateralization rate, and that would break our entire system, right? That would break our invariant, and our system will be screwed. So we can go back to the drawing board, figure out how to smooth this out, or we can say this is a known bug. If the price fluctuates or explodes too quickly or too slowly, this protocol becomes worthless. And that's kind of not a great solution, right? So these are things we absolutely want to keep in mind. And these are things that we can find with invariant tests. And this is why they're so important. So for now, in our handler, I'm actually just going to even comment this out because it does break our test suite. But I'm going to put a little comment here. This breaks our invariant test suite. And this would 100% be something that shows up in a smart contract audit saying, hey, if the price of an asset plummets too quickly, the system's breaking because it breaks the invariant. All right, great. Now there's a few more things I want to teach. Only a few, and then we're done with this section. We're going to teach 1, some proper Oracle use. And then 2, we would need to write more tests, which we're not going to do. I'm going to leave that to you. But we have a whole bunch of other contracts in here, like the decentralized stablecoin. And then 3, some smart contract audit preparedness, some smart contract audit preparation. So let's start with some Oracle proper use.